All right, so in this video, we have this open top box over here where the bottom is filled up with the top is empty. And this 3D box is split into two compartments, split by one middle division there. I've drawn the diagram as best as I could, but as you can tell, I'm not an artist. And the goal of this video is to minimize the area of the box so that we can minimize the cost basically. And we have to have a volume of 48 centimeter cube for this box. So the first thing I'm going to do, like any problem like this, is you got to come up with your equations. I know volume of this box is just x times y times z. So x, y, z equals to 48. And then I'm going to come up with an equation for the area of this box. The area of this front over here is just xz, and then the back is also xz. So that's 2xz. The area of the bottom is xy plus xy. I should have probably written that first. And then the side over here, which there are three sides basically, there's one in the middle as well technically, is just yz. So plus 3yz. Once I have my two equations, remember I need to minimize my area to minimize my cost in this question. So if I want to minimize my area, there's three variables here. I honestly don't know how to do it with three variables and then find the minimum area. But we have a second equation here. We can get rid of the one of the variables here. I'm just going to isolate z in this equation. And then I'm going to replace my two z's with 48 over xy. Just going to write this xy term first, and this is just 2x times 48 over xy. And then this is 3y times 48 over xy. I can simplify this equation a bit. So xy plus 2 times 48 is 96. X's just cancel, so 96 over y basically. But I'll write that as 96y to the negative 1, just so it's easier to derive in the next step we're going to do. And this over here, 3 times 48, I'll do that in my calculator. 144. The y's cancel here, and I'm just left with an x in the denominator, so I'll write it as x to the power of negative 1. So now that I have my area equation in terms of two variables, I know I can derive this using the Hessian matrix. I can classify my points as maximums, minimums, or saddle points, basically. So I'm going to do that whole routine over here. I'm going to derive it, find my critical points, and then classify them to find minimum area of this box. So let's start with finding a of x, which is basically deriving this equation in terms of x and pretending that y is just a constant. So the derivation of xy would just be y, and the derivation of 96y to the negative 1 is 0 because this is all a constant. And then the derivation of 144x to the negative 1 is minus 144x to the negative 2. And then I'll derive the same equation in terms of y as well. If I derive in terms of y, I'm pretending like x is a constant, so the derivation of xy is just x. And then the derivation of 96y to the negative 1 is minus 96y to the negative 2. And then this is just a constant, so it disappears. And then I want to make both these equations equal to 0, and I want to solve for my x and my y to find my critical points. So 0 equals to y minus 144 divided by x squared. I can't solve this by itself, which means I have to go to my second equation. 0 equals to x minus 96 over y squared. And then I need to solve for either x or y here. So I can just move this y, or actually I'll move this term to the other side just to make it positive. 144 over x squared equals to y. And over here, I'll move this term to the other side just to make it positive. So 96 over y squared equals x. Then I will just cross multiply this x squared over. So 144 equals to x squared y. And then I'll replace this x with 96 over y squared. I'm doing substitution here. Squared times y. 96 squared, again, I'll do that in my calculator. So 144 equals to 9216. Y squared squared is y to the power of 4 times y. This y and 4 will cancel to give me a y cubed. So 144 equals to 9216 over y cubed. I'll cross multiply these two over. So y cubed is just 9216 over 144. And I'll do this in my calculator. I get y cubed equals to 64. If I cube root, I will get y equals to 4. Now that I found my y value, let me sub it in here for my y to find my x value. So 96 over 4 squared equals to x. 96 over 16 equals to x. So x just equals to 6. So I've got my critical point over here. My critical point here is 6, comma 4. I guess there's going to be a z value for this as well, which we can eventually find using this equation over here. But before I do that, I need to, technically the bracket doesn't close, there's a z value here. But I need to prove that this is a minimum before I even find my z value, because since this is the only critical point, it's most likely going to be the minimum, but you have to prove it just in case, because some questions you might have 2 or 3 critical points. You need to find the minimum of the critical point. In this case, we only have 1 critical point, so it's most likely a minimum. But again, I'm going to show all the steps, because if you found like 2 or 3 critical points, how do you know which one would be the minimum? So in order to prove that this is a minimum, we have to use the Hessian matrix. So the Hessian matrix, if I simplify it, is basically fxx times fyy minus f square of xy. And if h is greater than 0 and fxx is also greater than 0, then we know it's a local minimum. And this is what the case we're looking for right now. If h is greater than 0 and fxx is less than 0, it's a local max, which would be no good for this question. But that would be good for like maximizing profits or some kind of question like that. And then if h is less than 0, it's basically a saddle point. So these are the 3 most common cases. There's also a 4th case as well where h equals to 0, but that basically means you can't figure out what the critical point is. I'm not going to really discuss that. So let's find out fxx, fyy, and f square xy. Let's start with fxx. Or technically in this case, it's going to be axx because we have an area equation rather than f equation. So axx just means I'm re-deriving my ax equation in terms of x, so y is a constant. So this is going to disappear as 0. If I derive this in terms of x, I'll get positive 288 x to the power of negative 3. And I'll find a y next. So I'm just deriving a of y in terms of y. This is going to disappear. This becomes positive. 96 times 2 is 192 y to the minus 3. And then I'll leave a bit of space because I'm going to simplify those in a second as well. I'll find AXY. Find AXY, you can either derive AX in terms of Y or AY in terms of X. Doesn't matter, you should get the same answer for both. If I derive this equation in terms of Y, derivation of Y is 1. And the derivation of any constant, I'm pretending like X is a constant, that's just 0. So that's my derivation of AXY. These two I can simplify to 288 over X cubed and 192 over Y cubed. Then I want to sub it into my Hessian equation, which is just fxx times fyy minus f squared xy. So that's just 288 over x cubed times 192 over y cubed minus axy squared, so 1 squared. So now all I have to do is sub my critical point into this over here, and then I have to place it under one of these conditions. Okay, so let me start by just subbing in my critical point into my AXX. So 288 over my X value is 6 cubed. And if I put this into my calculator, 288 over 6 to the power of 3 is positive 4 over 3. So it's good that we get greater than 0. Now all we have to prove is h is greater than 0. So I'll find my AYY really quick as well. So this is just 192 over y is 4, so 4 cubed. So 192 divided by 4 to the power of 3 is just 3. So I'll sub these in for these two things over here, these two calculations. So 4 over 3 times, this is my h by the way, my Hessian. 4 over 3 times 3 minus 1 squared is just 1, which is just 4 minus 1, which is 3. So as you can tell, my h is greater than 0, and my f, I guess AXX in this case, but FXX technically, AXX is also greater than 0 because I got AXX to be 4 over 3 and h to be 3. Both of them are greater than 0. And if both of them are greater than 0, I have proved that this point, therefore the point is a local minimum. And again, in this case, I said that was most likely because we only had one critical point. The only reason you really want to do all these calculations is to confirm your answer. And in cases where you have more than one critical point, you'd have to find which one of the critical points is the lowest minimum, basically, or the only minimum, I guess. So my critical point is 6, 4. I can find my z value by substituting my x and y back into this z equation. So z equals to 48 divided by 6 times 4, which is 48 over 24, which is just 2. The z value is 2. So this box is 6 centimeters by 4 centimeters by 2 centimeters. And that's going to be the dimensions that will minimize my area, therefore minimizing my cost. If you made it to the end of this video, please hit that like and subscribe button as it really helps the channel. Thank you.